Welcome to Formula 1 Maths. This is 5.2 of the Applied Maths course, Year 2, A-Level. We are going to learn how to solve problems involving smooth and rough inclined planes. Forces can act on a body on either a horizontal plane or an inclined plane. For a horizontal plane, the forces are resolved horizontally and vertically. Also, the normal reaction acts vertically. For an inclined plane, the forces are resolved parallel to the plane or along the plane and perpendicular to the plane. The normal reaction acts perpendicular to the plane. So that's the difference between bodies that are on a horizontal plane and those that are on an inclined plane. There's one thing which is common for both, and this is the weight. So in both cases, the weight acts vertically because acceleration due to gravity, G, is always in the vertical direction. That means for an inclined plane, we need to resolve the weight along the plane and perpendicular to the plane. So let's go and do that. So we have a situation like this here, where we've got an inclined plane, inclined at an angle alpha to the horizontal. And like we said, the reaction is perpendicular to the plane, as you can see. And in some cases, the force acting on the body is also inclined to the direction of motion. It will not always be the case, but in most cases we have this situation. We also have the weight acting vertically, like we said. So we need to resolve the weight. So for an inclined plane, all forces, including the weight, should be resolved along the plane and perpendicular to the plane. So the force F can be resolved into F cos theta, which is along the plane or parallel to the plane, and F sine theta, which is perpendicular to the plane. Then for the weight, we have this situation here, which is perpendicular to the plane, and another one parallel to the plane. So this one can be moved up here and to be along the plane. It's the same thing. Now we need to find this component and that component. To get these components, we need to find this angle here. So we've got the situation repeated here. And so I need to find this component and this component. But like I said, we need to find this angle before we can resolve the weight into this component and that component. So let's say this angle here is x. If this is x, and then we consider this is 90. So if that's 90, then this angle here will be 90 minus alpha. And because this here and the blue line are perpendicular, we can also say that x plus 90 minus alpha is equal to 90. Because, again, this is 90 degrees. So this plus that is equal to 90. So x is here, and this angle is 90 minus alpha. So let's evaluate x. So if I remove the bracket, I'll get x plus 90 minus alpha equals to 90. That means x minus alpha is equals to 90 minus 90. That means x minus alpha is equals to 0, and means x equals to alpha. So x is equals to alpha. And it will always be the case that this angle here is alpha, which will always be the same as that. In exam, you will not be asked to prove this. I'm just showing you how this angle can be proved that it's the same as that. So now that we've got the value of this angle, we can resolve the weight into mg sine alpha, because remember, this is opposite the angle and the opposite side of a right angle triangle. By the way, this is a right angle triangle because this is 90. The opposite will be the weight which represents the hypotenuse times sine alpha. And that means the blue one is mg cos alpha. So this is how we resolve the weight into components parallel and perpendicular to the plane. So now that we've done that, let's go and see how we can use that to solve some questions. Question 1. The diagram shows a box of mass 5 kilograms being pushed up a smooth plane by a horizontal force of magnitude 16 newtons. The plane is inclined to the horizontal at an angle alpha, where tan alpha is equal to 3 over 4. Find A, the normal reaction between the box and the plane. B, the acceleration of the box up the plane. So first of all, you need to put in your forces and resolve the necessary ones you need to resolve. So let's go and do that. So the first force I put in is the normal reaction force. That's the weight. And then this can be resolved into this and that. Then we need to find the values. So this angle we know is alpha. So that means this component is 5g cos alpha, and that component is 5g sine alpha. So now that we've got that, we need to resolve the 60 Newton force into 60 sine alpha and 60 cos alpha. Please note that this angle here is equal to alpha because this is horizontal. And if you look at very critical, consider this one and this are alternate angles. This and these are alternate angles. Again, it will not always be the case. It's only the same to this because this force is acting horizontally. So that is alpha, and that's why we can get 60 sine alpha here and 60 cos alpha here. So we've got all the forces in there. This force now goes away because it's represented by 60 sine alpha and 60 cos alpha. So we can now go and solve our first question. To solve the first question, first of all, you draw a right angle triangle like this. And because it says this is tan alpha, we can put 3 here and 4 over there because tan alpha is opposite over adjacent. And that's exactly what we've got here. Now, using Pythagoras' theorem, we can find the hypotenuse, h, to be equal to square root of 3 squared plus 4 squared. And that will give us 5. So we've got all the sides of that. Now we can write down sine alpha and cos alpha. So sine alpha is opposite over hypotenuse. Cos alpha is adjacent over hypotenuse. And we've got that, and we can use that in our solution. So now let's go and try to solve the first question, the normal reaction between the box and the plane. So because the box is not moving off the plane in that direction or going through the plane, we can say all the forces going this way will be equal to all forces coming this way. So that means that we can write our first equation down, which will be R equals to 60 sine alpha plus 5g cos alpha. But we know the values of sine alpha and cos alpha, so we do our substitution to get that. And then when we evaluate, we get 75.2 newtons. And that's the normal reaction. For B, we use Newton's second law of motion. So here we have F equals to ma. So we are going to look at the components along the plane. So we've got two components along the plane, 60 cos alpha moving up and 5g sine alpha moving the opposite direction. So the force propelling it along the plane or up the plane will be 60 cos alpha minus 5g sine alpha. So we get this. 60 cos alpha, that's this one, moving it up, minus 5g sine alpha, opposing the motion. So it's going to be negative. That will be equal to 5 times A. So that is our force, big force, propelling force, equals to m times A. So that's our Newton's second law. All we do now is do our substitution, and then we can solve for A. So we get this, and finally, we are going to get 3.72 meters per second squared. So that's it. That's how to solve that using Newton's second law of motion. So let's go to question 2. Question 2. A block of mass 20 kilograms is released from rest at the top of a rough plane. The plane is inclined to the horizontal at an angle 30 degrees. After 6 seconds, the speed of the block is 21 meters per second. As the block slides down the slope, it is subject to a constant resistance of magnitude R newtons. Find the value of R. So I have drawn the situation like that. And this question did not come with a diagram, so you have to learn how to sketch your diagram. So that's the 20 kilogram force at the top of the plane, moving down this way. So it's going down this way. And so let's put in all the forces. So the first one will be the normal reaction force, which is perpendicular to the plane. The opposing force, which is along the plane. And the weight. But as you know, we need to resolve the weight into perpendicular component and one that is parallel to the plane. That is 30 degrees, as we explained in the earlier question, which is the same as that. That means this is 20g cos 30. That's 20g sine 30. And now we are looking for the resistance, R. So we're going to use Newton's second law of motion. In Newton's second law of motion, which is F equals to ma, we can see that we've got a mass, we've got a force, because the force propelling this will be 20g sine 30 minus R. So we've got F, we've got M, we don't have A. But we are given information to find A. The information given are as follows. Initial velocity is 0 because it starts from rest. Final velocity is 21 meters because after 6 seconds, time t 6 seconds, the velocity is v. So the silver equation that comes to mind that will help us or enable us to find A is v equals to u plus at, which implies that A is equals to v minus u over t. So let's go and do that and do the substitution. We get 7 over 2 meters per second squared. That's the acceleration. We now go and use our Newton's second law of motion. And this is our force that is moving the body down. So this is in this direction, and this is going the opposite direction. So that's where we have this minus r equals to the mass times the acceleration. But we know the mass and we know the acceleration. So let's do our substitution. If you do our substitution, so the only unknown now is r. So all we have to do is rearrange and solve. So that gives me 10, this one gives me 10, and this gives me 70. So rearrange together, evaluate to get 28 newtons. And that is how to get R. Again, thank you for watching, and I'll see you in the next video.